Welcome to the Learning Pines YouTube. We hope this video helps.
You begin by getting the minimal toolchain and math you will actually use. Install Python 3. 10+, create a virtualenv and pip install Qiskit or circ, test the simulator. Learn the linear algebra you need, complex amplitudes, inner products, and tensor product composition. Once done, create a notebook with a single qubit circuit and run it on the simulator to confirm your environment. Make sure to save versions and document package versions so experiments stay reproducible. Next, design simple circuits and iterate toward useful experiments. Start with state preparation and apply gates like X, H, and CX. Measure and record outcomes to estimate probabilities. Simulate noise models and run parameter sweeps to understand sensitivity. Visualize histograms and error bars. Once you see expected behavior, transpile the circuit to match target hardware connectivity and native gate set. Then schedule short jobs on a real backend. Keep notes on. Finally, optimize and deploy your experiment to get meaningful results. Reduce circuit depth and gate count, merge rotations where possible, and apply error mitigation techniques to raw counts. Run the job on hardware using short queues and calibration-aware transpilation, then post-process results to extract metrics. If outcomes are wrong or noisy, first run miniature tests, verify qubit mapping, recheck calibration data, and run identity and tomography checks to isolate noise or readout bias. Then adjust the circuit or retry with mitigation and shorter circuits.
Thanks for watching. Consider subscribing if we helped you.